Think about baking a layered cake from a recipe card. First you pour the batter and bake the base, then you let it cool and set hard. Then you spread the frosting on top of that finished layer, let it set, then add the fruit on top of that. Each layer goes on in order and locks in place, and you can never reach back and change the base without redoing everything sitting above it. If you bake the same cake again from the same card, you reuse the layers that did not change and only redo the part you altered. That is almost exactly what happens when you type Docker build, where a recipe file gets turned into a stack of frozen, stacked layers that become your image. Most people treat the build as a black box, so they cannot explain why their image is 1.2 gigabytes, why a tiny edit triggers a full rebuild, or why a secret they deleted still leaks. Understanding the build pipeline fixes all three. A Docker build reads your Dockerfile top to bottom and turns each file-changing instruction into a read-only layer. Modern Docker uses BuildKit, which models the build as a graph of steps, runs independent steps in parallel, and assembles a final image made of those layers plus a JSON manifest and config describing them. The CLI packages your build context, the folder you pointed at, into a tar stream and sends it to the BuildKit builder, which is why a stray node_modules folder makes builds slow and a Docker ignore file makes them fast. BuildKit parses the Docker file into a dependency graph called LLB, so steps that do not depend on each other, like two separate copy lines, can run at the same time. For each run instruction, BuildKit starts a temporary container from the current layer stack, executes the command, and captures the file system changes as a new layer. For each copy, or ADD, it hashes the source files and writes only those files into a new layer, with no temporary container needed. After each step, the resulting layer is content addressed by a SHA-256 digest, so identical steps across builds and images point to the very same stored layer. BuildKit checks its cache before running any step, reusing a layer when the instruction text and input checksums match exactly, and rebuilding from the first mismatch onward. When all steps finish, BuildKit writes an image config holding the environment, entry point, and the ordered list of layer digests, plus a manifest that ties the config and layers together. That manifest gets a digest of its own, which becomes the image ID you see, and the whole thing is stored locally ready to run or push. A Node app that copies source before installing dependencies rebuilds npm install on every code change, taking 70+ seconds each time. Reordering to copy package.json first, install, then copy source, drops rebuilds to about 3 seconds because the install layer stays cached. Same app, same result, one ordering change. A dangerous misconception is that deleting a file in a later run removes it from the image. It does not. The file still lives in the earlier layer where it was created, just hidden by a whiteout marker. So a leaked API key baked into an early layer is still fully recoverable by anyone who pulls the image. The real fix is to never let the secret hit a layer, using BuildKit secret mounts or multi-stage builds instead. Like that layered cake, a build is a chain of layers, each one frozen and hashed, where order controls caching and every layer is permanent. So think in layers and your images get smaller, faster, and safer. I take one piece of container tooling apart every single day, so it finally makes sense. Subscribe to TechWithJoel. What is the strangest reason your build cache ever broke? Tell me the story in the comments. Subscribe to TechWithJoel.